Hey, how's it going, everybody? Today we're going to do a brief introduction into model-driven telemetry and followed by a demo with the Cisco XRV image, Pipeline, InfluxDB, and Grafana. Just so you know, all the link references for what we're going to talk about is going to be in the video description. And also, you're going to be able to find all the configuration files and instructions in my blog post. And the link will be available as well. So simply put, model-driven telemetry, or MDT, is meant to be the replacement of SNMP. And there's a few reasons behind this. For instance, instead of dealing with OUIs and MIPS, we're going to be dealing with Yang models. And this all kind of ties back to the whole open source concept that vendors like Cisco, Juniper, and others are finally pushing and catching up to. And I say this especially because of tools like Pipeline. And Pipeline is an open source MDT collector designed and promoted by Cisco. And it easily interoperates with other open source stacks for like data analytics, telemetry, and remote management. Another benefit of MDT is the flexibility. There's a few different ways in which you can establish the telemetry session, and furthermore, different ways to encode the data. So before we get into the demo, let's take a look at some of the basic concepts of MDT. So these are kind of like the three main knobs or settings that you can play with when turning up a telemetry session. Dial in or dial out simply refers to who initiates the streaming session. So whenever you hear dial in or dial out, just remember this is from the client perspective and not from the collector. So that a dial out session is when the router initiates the connection to the collector, and a dial in is when the collector initiates the connection to the router. As far as the transport mechanism, we have our classic TCP and UDP, but there's also this one called gRPC, which stands for Google Remote Procedural Call. And this one works over HTTP and allows for added security like TLS. So this is probably what you're going to find in most of the production environments. As far as the encoding, and this is how we serialize the telemetry data onto the wire, and how do we decode that later when it arrives at the collector. The most common option is GPB, which stands for Google Protocol Buffers. This one has two flavors. So GPB uses these things called protofiles, which basically tell the collector how to interpret the data that is being sent by the router. Uh, so to make it simple, the compact GPB is kind of like more cryptic in the sense that it requires a protofile for each sensor that you're trying to stream, while the self-describing GPV, which is also known as key value GPV, it only requires a single protofile, no matter how many sensors you have, and the data arrives in kind of like a format that is easier to understand. Compact GPV is on average 3 times smaller than self-describing GPV, and at least 2 times faster. Okay, so this is what the configuration looks like for a Cisco XRV image, which is running iOS XR. And I think I found it pretty straightforward. So the hierarchy is called telemetry model driven. And the first thing that you're gonna want to do is set up your destination group. Um, so this is where you basically tell, well, what's going to be the IP address of the collector and what port is that listening on. Unless this is a dial-in connection, but in this case, this is going to be a dial-out connection. Um, Here you can also specify what encoding you're going to use. So in this case, I'm using self-describing GPV and the transport protocol, which is in this case we're going to stick to TCP. Next, you need to define your sensors. And this is where things start to get a little bit interesting, because if you notice all the sensor pads, um, these are going to be the Yang model files, basically. And I'm going to show you how to look this up on the GitHub repository as well as on the actual router itself. And this is where you do most of the filtering, because the more specific you get on the sensor pad, basically the less information that you're going to stream. Um, Now there's a rule that you can't do more than 15 containers, um, but there's a way to remove that ever since 6.2 or something like that on iOS XR. Um, and then lastly, you have the subscription, which is where you tie the sensors to the destination group. And this is where you also set the interval. So this is going to be sending out data every 5 seconds. So let's talk about pipeline. And this is the setup for the little demo that I'm going to show you. And as we said before, Pipeline is an open source MDT collector developed by Cisco. It's written in Go language, and its main function is to receive the incoming telemetry data, decode it, and spit it out onto your different systems. Some of the most common plugins are Prometheus, InfluxDB, Kafka, and Logstash. Pipeline is really easy to get started with. You simply define your transport inputs and transport output sections in the configuration file, and basically off you go. Uh, this over here is the configuration file that I'm using for the demo, which defines the properties of the streaming session from the router, as you can see here in the from router section. So this basically is information that matches the configuration that we have on the router. And this over here is the transfer output section, which basically tells Pipeline how to send the data onto the time series database. In this case, it's going to be InfluxDB. We're also going to be using Bird, and Bird is a configurable routing daemon for Unix. We're going to use it to create the external BGP and OSPF peerings with the XRV router, and we're going to push some 20,000 BGP routes and 15,000 OSPF routes, just so that we get some data to graph. Now, if you take a look at the diagram, everything except the XRV router is going to live inside my Ubuntu VM. So this over here is the virtual machine. And I'm running both Pipeline and Bird directly from the Ubuntu, while Influx and Grafana, these two are going to be Docker containers. So basically everything except the XRV has the 10.0056 IP, which again is the Ubuntu, and we're basically gonna use different ports to access each one of the services on the 56 IP. The end result is that we're going to be able to use Grafana to pull the InfluxDB and generate our graphs. We're also going to be able to verify a few things along the way, which you're going to want to know how to do when needing to troubleshoot.